Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein and I'm a PL/SQL developer just like you. This lesson is the latest in my series on programming with collections, the array-like structures of PLSQL, and the focus of this lesson is set-level manipulation of nested tables, one particular type of collection, essentially built around the multiset keyword, though not restricted to it. Some quick reminders. If you haven't already done so, download the demo zip file and supporting PowerPoints from PLSQL Obsession, toadworld.com/sf. For all the different scripts that I run in my application, in my lessons, you'll find them here in the demo.zip file. Just download that and unzip it, and then open those files as you go through my video trainings and try it out yourself. Click on Trainings, Seminars, and Presentations to drill down into the set of PowerPoints that support all of my different trainings. In addition, make sure you're comfortable with the material covered in the previous lessons in the series on collections. There are a lot of them. Collections are a very large, complex feature in Oracle. And most importantly of all, make sure that you watch and are comfortable with working with nested tables. That's the only type of collection that the features I'll talk about in this lesson apply to. So manipulating nested tables as multisets or set-level operations. First of all, from a theoretical standpoint, a nested table is a multiset. A multiset is a mathematical concept or structure in which there is no inherent order to the elements, and duplicates are allowed and are significant. For example, relational tables are multisets. Unless you specify an order by on your select statement, you're never guaranteed the order of the data you retrieve from the query. And of course, unless you have a unique index, you can have duplicates. Rows can have the same data in them. So relational tables are multisets. Turns out that nested tables are also multisets, or intended by Oracle to be treated as multisets. And if a set has no order to its elements, then it in effect has no index. And therefore the only way to manipulate the data in that multiset is as a set, not as a programmatic structure in which you iterate through them element by element. Now, as you know from working with nested tables, there is an index available in a nested table, so Oracle kind of cheats. You can use the index to iterate through the elements of a collection, but in Oracle 10G and higher, you can also manipulate that nested table as a set. So Oracle added the multiset operators to perform set-level operations on nested tables, and they can be used in both PL/SQL blocks and in SQL statements. In fact, the multiset is a SQL function, or it's a SQL operator, that was also made available in PLSQL. So let's take a look in a lot more detail at the set-oriented features for nested tables. First of all, you can use these features to determine if two nested tables are equal or unequal without having to write a program to iterate through them. You can check to see if a nested table has duplicates and remove those duplicates. You can check to see if one nested table contains another as a sub-multiset, and find out if an element is a member of the nested table. So nice high-level operations, and even on a higher level, I can perform set operations. So join the contents of two nested tables with the Multiset Union. Return the common elements of two nested tables with Multiset Intersect, and take away the elements of one nested table from another with Multiset Except. Strangely enough, it's not minus, which is the standard SQL set operator. It's except. So, checking for equality and inequality. You can use the standard operators for equal and not equal, and there are actually lots of different ways to say not equal besides that. But in any case, any of them will work to compare the contents of two nested tables. I'll come back to my comment about nulls in a moment. This is a big advantage if you need to compare the contents of two sets of data over writing a program to do that comparison. Let's take a look. First of all, let's take a look at the old way of doing things. If I really needed to write a program to do this, 10G compare old. So here's a program that compares the contents of two nested tables of employee records, and essentially, to find out if they're equal, I have to iterate through the collections and check for a match. And of course, for complex structures like records, I have to write my own equality check. But the bottom line is that I'm writing a program, and in fact, this isn't even enough. I check to see if the count is the same. I check to see if one is in the other, but I also need to check to see if the other is in this one. So it involves writing a fair amount of code. And instead of doing that, when working with nested tables and nested tables only, I can instead use the equal operator. So in this piece of code, I've declared a nested table of strings called clientele. And basically they allow me to keep track of my list of clients. So I've got customer 1 and 2 in client list 1, 2, customer 1 and 3 in 1, 3, customer 3, 1 in 3, 1. You get the idea by the name. And then in the last two, I've added a null. So a null into 13, 1, 3n and 3n, 1. So different orders, different combinations. And I've got my program called compare clients. So if they're equal, if the two nested tables are equal, then display that they're equal. Otherwise display that they're not equal or null. I run my script and I see the following. So 1 and 2 definitely not equal to 1 and 3. 1 and 3 is equal to 3 and 1. 1, 3, 3 is not equal to 3, 1. Duplicates are significant. That's a different set. 1, 3 null compared to 3 null 1 results in a null result. In other words, essentially if you have nulls in your lists, in your collections, then Oracle will return null for the comparison, even if they each have a single null. So as usual, nulls have a kind of disruptive effect on your computations, and you need to make sure that you're aware of whether or not your nested tables have nulls. But beyond that, all you need to do is use the equality operator, and Oracle takes over from there. Nested table duplicates. So a multiset is a data set that can have multiples of the same values. Duplicates are significant. A set is a multiset without duplicate values. And you can use the set operator to determine if you have a set of distinct values and also to remove any duplicates. So for example, I declare my nested table of strings. I get rid of the duplicates, so I apply the set operator to my nested table and it returns a new nested table without duplicates. I can ask, is it a set? Are there all distinct elements, or is it not a set, which means does it have duplicate values? I would have thought that Oracle would have done, is it a multiset, is it not a multiset, since it's the multiset feature, but that's it. Is it a set? Is it not a set? Let's take a look. Now in many of the examples in this lesson, I'll be using the authors package. And what I'm doing here is creating a nested table of strings. I've got 3 different nested tables at the package level. My favorite authors, my wife's favorite authors, and the favorite authors of my son Eli. I have a show authors program that basically iterates through my collection and just displays them. I have an initialization authors program that initializes the authors. So here are my 6 favorite authors. Here are my wife's 3 favorite authors and my son's 3 favorite authors. My son has all the same authors as I do and not as many. My wife has a different favorite author, Anne McCaffrey, that is not on my list. So 3 different lists of information. Let's compile that package. And I'll use this over and over again as I explore the different multiset capabilities. All right, now let's take a look at the 10G set script. So in my set script, I declare a list of strings, distinct authors. I create a Boolean display value, Boolean put line. So basically I can display the value of a Boolean as true, false, or null. I'm going to initialize my list of authors. I'm going to add a duplicate author to my list. So I'm going to extend the nested table, package.nestedtable.extend. I'm going to add Robert Harris as a second time into my list. There's Robert Harris once, then Robert Harris twice. And then I'm going to do a distinct on my authors. And I'm going to take a look at the full set of authors so we can see that there's a duplicate. I'm going to ask, is my list of authors a set or a multiset? So it does have duplicates. That should show me false. And then I'll take a look at the distinct authors and ask the same questions there. And then we've got a variety of things here to add nulls and see what impact that has. So let's run this code. Look at the results. There's my full set. Notice Robert Harris twice. Is my set distinct? No. Is it not distinct? Yes. Let's take a look at the distinct set. I got rid of the Robert Harris duplicates, and now my authors is distinct. And my authors with one null distinct is true. So basically what I'm showing here is that if you have one null, it still registers as distinct. If I have multiple nulls, then it will be not distinct. So the distinct analysis also applies to null values. So that's the set operator. Determine if a value is in a nested table. Oracle added a member of syntax in 10G to determine if a value is in a nested table. It's a very simple form of syntax, really, really nice. You don't have to scan the collection looking for a match. You can say, well, is it a member of? It performs an equality check for the entire element. In other words, if I had a collection of records or a collection of object types, you cannot ask, is it a member of, and just look for a match on a specific sub-element. It's the entire element, or nothing at all. And the thing to note is that you can use member of syntax in SQL and in PLSQL. But in SQL, at least through Oracle 11G Release 2, there's some kind of bug regarding performance, and it's something that you should avoid using in the SQL layer. To see an example of that, let's take a look at my in-clause script. There are a lot of different files for in-clause, as you can see here. And I'm not going to go through all of this. Basically, it's an examination of the different ways that you can ask to see whether an element is in a dynamic list of values. And just to cut to the chase here, here's an example of the syntax using member of. I pass in a list of values, and I say, find all the rows in my table where the ID is a member of this list. So you can clearly see it's very nice, simple syntax. The problem is that in SQL, this is quite slow. So if you do have a dynamic list of values and you want to use SQL to determine whether or not they're there, the simplest approach is the following. Pass in the simplest approach and also the most performant, acceptable for production. Pass in your list. Select from that list using the table operator. That essentially converts my nested table to a relational table format. And then I can select the column value from that list, ID in. So this is the preferred format for multiple in values. Member of is really nice syntax, but it's buggily slow in Oracle, up through Oracle 11.2. However, in the world of PLSQL, not a big deal. No problem with performance. Here's an example of declaring my list of clients and then asking if this string is a member of this collection, then take a certain operation. If it's not a member of, here are some other things that I'll throw in here while I'm here because I don't cover them in the notes. You can also ask for the cardinality, which is the same thing as asking for the count of elements in your nested table. And you can ask, is it empty or is it not empty? Obviously it's empty if the cardinality is 0, if the count is 0. So I run this script. Customer 1 is in the 1-2 list. Customer 2 is not in the 1-3 list. There's my cardinality. It is empty. It's not empty. So again, very high-level syntax that automatically performs analysis on the nested table without you having to write a program to do it. Member of being the most important. The rest of them, cardinality, is empty, is not empty, are pretty much conveniences, but nice to have as well. So again, if you need to just know quickly if inside your PLSQL code a value is inside a collection of that type, so if it's a list of strings, a list of numbers, list of dates, then use the member of syntax. Does one nested table contain another? So the sub-multiset of operator determines if all the elements of one nested table are in another nested table. Simple syntax, declare your nested tables and populate them if this nested table is sub-multiset of that nested table. Let's take a look. So I'm going to initialize my authors. Let's make sure I do that first. Init authors. I've got, again, my Boolean put line. And I've got my list of Stephen authors and author authors. And again, notice that my son's list of authors is entirely contained inside my list of authors. The son takes after the father. How nice. It's probably not true anymore. This is from years ago. Anyway, so Is Stephen a multiset of Eli? No, it shouldn't be. Is Eli a multiset of Stephen's list? Yes. Let's run the code. So father follows son? No. But the son follows the father? Yes. So that's it. Again, very nice high-level syntax for simply saying, are all the elements of this nested table in this nested table? Sorry, other way around. Is this nested table inside this nested table? Without having you doing the looping process, the algorithm, to determine it. All right, let's take a look at the high-level set operators, and then we'll be done. So union two nested tables together. Just like SQL has a union, nested tables have a multiset union. So the difference with multiset union is that differences are preserved unless you include the distinct modifier. That's the opposite of the SQL union and union all. And whenever you perform a union, a multiset union, the resulting collection is either empty or sequentially filled from index value 1. Also, you do not need to initialize or extend first. Let's take a look. So I initialize my set of authors, and then I'm going to do a union of mine and my wife's favorite authors, multiset union. So if I try to do a union, that's an SQL operation alone. It's not for nested tables, it's for relational tables. If I want to provide these operators or apply these operators to nested tables, I need to prefix it with the multiset keyword. So union my two lists together, then we'll see what they look like. Also, I can use multiset inside SQL. So here's an example of doing the same join, essentially, the union together of Viva's authors and my authors. Inside a select statement, I use the table operator to take the result of the union, turn it into a relational table format, and then select from it. And then I'm going to do a multiset union distinct. And that means get rid of all duplicates. Run my script. And here's what I see. I see what? Let's try that again. I have to look at the right place. So let's do it one more time. Here's my output. So my wife and myself are book lists together. Here it is. And notice we have multiples. So Robin Hobb is repeated. Sherry Tepper is repeated. Oh, and by the way, these really are great authors, and I encourage you to check out their stuff. Here's a union inside SQL. So notice it's in alphabetical order. Oracle orders them, which does not happen when you do it in PLSQL. Oracle automatically ordered them. And notice I do have repeats. I do have duplicates. And now finally, I do the multiset union distinct, and I've gotten rid of all of my duplicates. But notice still, it's not ordered. So there are a number of differences between the SQL union operation and the multiset union operation. One of them is that the SQL union gets rid of duplicates. You have to preserve them with union all. Multiset union preserves the duplicates unless you specifically say you want to make them distinct. In a way, the multiset operators are more pure in their conformance to the multiset rules than the union and intersect and minus in SQL natively. So that's union. Intersect. Use intersect, which means use multiset intersect to find the common elements of two nested tables. Again, duplicates are preserved unless you include the distinct modifier. There's also an all modifier, by the way, which is the default. That's the same thing as just saying intersect or union. Keep all. The resulting collection, again, populated from index value 1, or it's empty. No need to initialize or extend. Let's take a look at intersect. You're probably getting the idea. Well, here I've put my list of authors right inside my file, so I declare my list of strings, my various authors, and then I do a multiset intersect. I find all the common authors between myself and my wife, all the common authors distinct between the two of us, and then intersect all. So here are all the common authors between the two of us, and I've got a repetition of David Brin. In fact, that's why I put this code. That's why I put the author package right here. I've added David Brin twice just to show you that intersects do not automatically give you the distinct values. If I specify distinct, now we get rid of the duplicates. And if I specify all, it's just like doing the intersect without any modifier. It includes the duplicates. So that's intersect. And finally, take away the elements of one nested table from another. Use except. I don't know why they didn't use the keyword minus. But it's multiset except. Duplicates are preserved unless you include the distinct modifier. Collections always filled from index value 1, or they're empty. No need to initialize or extend first. Let's take a look at except. So again, a bunch of duplicates added to my list of favorite authors. Multiset Except. Take Viva's authors and minus mine. Multiset Except. Here, take my authors and take away Viva's from mine. And then do a Multiset Except distinct. So Viva has one author that I don't have. I have 3 authors that she doesn't have, but one of them is a duplicate. And if I do distinct, just down to the 2. So the bottom line is it works as advertised. It's quite efficient inside PLSQL. The multiset intersect and minus can also be used in SQL the same way that you see here. The result of these operations are nested tables. If you select from that nested table with the table operator, you can then manipulate those structures inside SQL as well as inside PLSQL. Conclusions. Bottom line is, if you're working with collections, let's say you start off with an associative array and you find that you need to do this high-level set manipulation. Just find all the common elements. Is an element in the list? Are there duplicates? Then what you might consider doing is switching or using a nested table, because these offer a powerful, simple way to avoid writing a lot of code. And let's assume, at least for the most part, that these implementations are going to run faster than they're going to run in your own PLSQL hand-coded algorithms. Set, sub, multiset, and member operators also come in very, very handy in a variety of circumstances. Just watch out for the results when your nested table might contain null elements, because you might get surprised by the answers. You might get nulls back when you're thinking you would get something else, and your logic is failing. So as usual, watch out for nulls. Make sure that you treat them as a separate value from whether they're equal or not equal, true or false. Nulls evaluate to nulls. Next steps. Download the demo zip. If you have not already done so, go to PLSQL Obsession, download the demo zip file. I provide you with lots of scripts in this lesson. I've gone over each one in some level of detail, but you should play with each one of them yourself. Make sure you understand exactly what's going on and how they work, the choices of syntax, and then you can start using them throughout your application code base. In addition, explore the other advanced topics for collections, working with non-sequential indexing with associative arrays, using string-indexed associative arrays, and most challenging of all, working with multi-level collections. There's lots to know about collections. Being an expert in collections will make you a top-tier PLSQL developer. It will help you write faster code and simpler code. So thanks for joining me. Hope you learned a lot, and happy PLSQL coding.